Okay, we're going to have a look at a buzzer now and how we can use that. Just to remind you of the circuit if you haven't seen it already, we've got a genie just wired up here with some PTMs, really simple, and this was going out to a series of LEDs. That was the first video. I then took one of the outputs here, Q0, and I connected it to a 4017, which later controlled the other 4017 as well. I then took Q1, which is here, and connected it to one of the 4026s, and that controls this display here. Okay, so although it looks quite complicated, it really isn't anything very complicated at all. I'm now going to take another output. I've got to stop that, haven't I? I'm going to take another output. I'm just going to get rid of that because it's no longer connected. I'm going to take this one, Q2, and I'm going to connect it to a buzzer. Okay, and I'm going to connect it to a buzzer here first and just show you that it doesn't work. What is it? Output component, I think, something like that. Loudspeaker buzzer. Right, here we go. It's polar. All right, sorry about that. Just a phone call. We're going to connect this buzzer, and what you would have thought is from the program that we've got, which I hope you've seen before. If I press D0, Q0 comes on. If I press D1, Q1 comes on. You would have thought if I press D2, then the buzzer comes off. It doesn't come on because you would hear it. And if I go to current flow here, what you can see is there is a bit of current flow, but it's not enough to actually allow the buzzer to sound. So we need something called a transistor. Okay, I'm just thinking where I'm going to put these transistors. I'm going to put them in here, I think. All right, so let's just stop that and go and get ourselves a transistor. So, and the idea with a transistor is an electrical switch, and so it's got a collector and it's got an emitter, and in the middle it's got a base. Well, two types actually. You've got a base, and so it turns the transistor on or off by a voltage or current being applied to the base. Okay. So the idea is that you connect that middle leg to the genie, and when that goes high, that allows electricity to flow through it if it's an NPN transistor, or if it's a PNP transistor, it's always on, and when you put electricity on that leg, it then turns itself off. It's an analog component, which means it doesn't just snap on and off, it will progressively let more electricity go through it or less electricity go through it. Depending upon the voltage. I think it starts at 0.6 and it finishes at 1.5. Anyway, you don't really have to know all that, but what we do need to do is I'm going to copy and paste that in, and we're going to put that there. Now, the buzzer is seen as the load, okay? So the load goes before the transistor. The electricity will be flowing in this direction, okay? Coming in at the, that's it, that's on there. Coming in at the collector, going out at the emitter, and it's the base that you need to connect to the genie. So let's just do that again. Okay, so I am going to, that needs to go high, but I'm going to connect Q2 to the base. Okay, and then I'm going to connect the high leg of the buzzer to the high of the circuit, and then we need to connect this to the low of the circuit, so I'm going to go down to those LEDs there. Okay, of course that is the low. So now if we play it, you can see the current flow. The current has gone up to the high leg of the buzzer, and if I press this one, you can see that it's much different. And that's working really well. So that's how you wire up a transistor and a buzzer.